Hello and welcome to another episode of TWiML Talk, the podcast where I interview interesting people doing interesting things in machine learning and artificial intelligence. I'm your host, Sam Charrington. In today's show, we're joined by Naveed Ahmad, Senior Director of Data Engineering and Machine Learning at Hearst Newspapers. A few months ago, Naveed gave a talk at the Google Cloud Next conference on how publishers can take advantage of machine learning. In this conversation, we dive into the role of ML at Hearst, including their motivations for implementing it and some of their early projects, the challenges of data acquisition within a large organization, and the benefits they enjoy from using Google's Bigquery as their data warehouse. Enjoy the show. All right, everyone. I am on the line with Naveed Ahmad. Naveed is Senior Director of Data Engineering and Machine Learning at Hearst. Naveed, welcome to This Week in Machine Learning and AI.
Thank you. Thank you for having me on your show.
So you've been in the publishing industry for about 10 years now. Can you tell us a little bit about both your current role and some of the past things you've done in publishing?
Sure. So I'm currently a Senior Director for Data Engineering and Machine Learning at Hearst. I've been here for about 2 years. My role has been building the data warehouse, building personalization, and also doing predictive analysis using that data. And before Hearst, I was at New York Times. I worked in the subscription space where working on their CRM system and also some of the aspects of machine learning like churn modeling and doing email content detection. And before that, I was in Thomson Reuters, where I also built their data news distribution platform, as well was part of their CMS team and contributed to recommendation systems. And before that, I was mostly in telecommunication.
And so you recently presented at the Google Cloud Next conference on applied machine learning for publishers. Before we jump into that topic, maybe you should take a second to provide an overview of Hearst for those who aren't familiar with the company.
Of course. So Hearst, I especially work in Hearst newspaper department. Hearst is a very large organization with more than 300 businesses, which includes magazines, investment, and television channel. And within even newspapers, there's about 40 plus websites, which includes names like San Francisco Chronicle and Houston Chronicle and Times Union. It is in Hearst headquarters located here at 57th Street in New York. And that's some background about Hearst.
So one of the things that you mentioned in describing your background and in our conversation before the interview started was the role of the data warehouse in enabling you to perform the types of machine learning that you want to be able to perform at Hearst. Can you talk a little bit about the data warehouse and the process for establishing it?
Yeah, so one of the first tasks for me when I joined Hearst was to build a data warehouse. Especially, I used Google Bigquery as a choice data warehouse. And the idea was that we need all the data sets in one place to be able to connect the dots, like to be able to look at what is the relationship between newsletter and the web and subscriptions. And the first use case was to build business intelligence on like regular reporting on top of this data. And the same data can be used to give data reports about current status can be used to do predictive modeling. So using query and basically we build data. Our data sets include Google Analytics, our content, our newsletters. So all sorts of data related to our business is in BigQuery. And this forms as a foundation for machine learning.
So the data warehouse is kind of central to your ability to perform machine learning and analytics, and it was one of the first things that you established at Hearst. Can you talk a little bit about any challenges that you experienced trying to centralize all of the data from these various sources?
The challenges were that our data was sitting in different formats. Like before data warehouse, people would get either data from individual systems or there's Excel worksheets going around. So really figuring out the data sources and then building a platform for ETL, that was the challenge. Some of the bigger data sources like Google Analytics and DFP, they were easier to get into BigQuery, but some of the ones we had to build specific code to ETL that into BigQuery.
And what is DFP?
Double click for publishers.
Okay. So that's your advertising system?
Yeah, this is all the log data for each advertisement, that impressions.
And so the data warehouse has your analytics, so the clickstream data for people that are visiting the site. It's got information about the advertising interactions and maybe those click streams. Does it also contain content information?
Yeah, so all our CMS content is in BigQuery. All our newsletter fiber data, that's in BigQuery.
And is that data replicated to BigQuery for analytics, or is that its native place and you're publishing directly to and from BigQuery?
Yeah, it is replicated. Like the other, we have a separate CMS system. It has our own database, so we're replicating that BigQuery. Yeah.
And these are very different types of data. What's the goal for pulling this all into a single place?
Yeah, so each of these data, they have identifiers that link them up with other data sets. For example, a newsletter via their hashed email address, you can link it up with subscription data. And from subscription data, we can link it up to Google Analytics data. So the idea is to be able to connect all the aspects of a user using these identifiers.
It sounds like the primary focus from an analytics, a predictive analytics, and a machine learning perspective is based on this linked data, this user-centric linked data?
Yes, absolutely.
And so maybe let's talk through some of the different things that you've done with the data from a machine learning perspective. What are the different challenges that you're trying to address?
So we built a few different machine learning based products and predictive models using this data we have in BigQuery. So number one, the one we're working on currently is a churn model, churn prediction. The churn prediction is that be able to predict how likely a subscriber is to cancel their subscription. And it's very relevant in the media space because it's a challenging environment to keep subscribers. Since we have subscription data, how people, their different attributes of their usage behavior, how many newsletter they signed up to, also customer service data associated with each subscriber. And the way it works is we take like a year old worth of data and take their attributes for the month and feed it into a machine learning model, and we know that in the next month, how many of those subscribers were canceled and versus who didn't cancel. So this is a binary classification problem. So, and using 6 months of data, we have training data of subscribers who didn't cancel versus cancel, and we can build a predictive model on it. So one of the things that we've done is, since we're on BigQuery, we've used this newly launched feature called Bigquery Ml, which was released in Google Next back in August. And what the great thing about BigQuery ML is that I can do a training and prediction model right using SQL syntax, i.e., you don't have to write code or Python code, and it does some of the like machine learning goodies like normalization of features and also fine tuning the model. And and one of the things that I emphasize is this enables people who don't even have machine learning background, like people in business intelligence or who have background in SQL, can easily write machine learning code just by using SQL syntax. So we built out our first model on San Francisco, um, and we're just working on integrating with our marketing and CRM systems. Um, so this was one of the use cases for machine learning. Then we've also built one of the things that I've done over here is use.
If I could jump in before you go to the next one of the things that really struck me at the Google Next conference, and not to turn this into a BigQuery commercial, but I was really surprised by the enthusiasm for BigQuery. Like people seem to really love that database. Can you like maybe net out for me why folks are excited about it and the BigQuery ML piece that they just announced?
Yeah, so in general, BigQuery is a fully managed data warehouse. So you don't have to have a DBA to fine tune or optimize the database. And it's based on Google's own internal Dremel technology. What I've heard is Dremel technology is heavily used inside of Google. And so they've exposed that as BigQuery. Um, and their philosophy is it's full scan. Any data set basically spawns off machines or compute in the back end and is able to very quickly get you results, especially if you have large data sets in terabytes or petabyte scale. Only takes a few minutes to run SQL. So it's very easy in terms of maintenance. It's based on SQL syntax, that's why it's very an attractive option for data mining. And BigQuery ML, so they built out machine learning on top of BigQuery, which even further, it's very fast because it's using the same compute infrastructure, and it abstracts out the machine learning as an SQL SQL. So it becomes, foresee that it'll enable machine learning for a lot of people, especially who are on BigQuery.
And so is the idea then that you'll have like, where you might have aggregators in SQL, like, average or max or something like that, you can apply some kind of model to, or is it different?
Yeah, it's absolutely. So just like these functions you mentioned, they've introduced a few different functions to be able to train and predict and even get machine learning metrics. Like once the machine learning model is built, to get, like, for example, what's the AUC of this machine learning or precision and recall. So you can do all of those things just by a function call with a SQL syntax. Yeah, as compared to using a tool like scikit-learn or TensorFlow, the other advantage is you don't have to take the data outside of the system. You do everything in one place. Like if you were using scikit-learn or TensorFlow, there's this whole process of extracting the data, massaging into a format that machine learning framework can understand, build a machine learning model, pull that data back into your data warehouse. So this whole cycle just gets reduced because you're doing everything in line in BigQuery.
You were about to go into another use case beyond actually, back on the churn. Yeah, I'm curious. This isn't necessarily a machine learning question. I've talked about churn prediction in many cases across many different industries, and I understand broadly how it's applicable. But I'm curious in the case of a publisher, what specifically is Hearst going to do on the business side once it's able to predict that a user has a high likelihood to churn?
Yeah, that's a good question. And we're working with marketing and people in the subscription business. What are the different ways? So some of the ways is that in our marketing platform, we're able to give messaging and be able to send emails. Typically, a user who is not engaged a lot are some of the people. Those are some of the attributes that are indicative that a person is going to cancel their subscription. So an email to nudge somebody, hey, did you know that there's a certain feature, or educating our print subscribers that they have free digital benefits, are some of the things that we can employ on getting people to lesser cancel their subscription.
You built this on Bigquery ML using this new SQL-like interface. Can you talk about how that experience of building these models using a SQL type of interface differed from traditional approaches? You mentioned scikit-learn. Like, how were they different? And I guess I'm particularly curious about the different skill level involved, but also any differences in the way you need to manage the models or the way you productize them, those kinds of things?
Yeah, that's a good question. So one thing is, getting started with BQML is really fast. I actually built the first prototype within a day. I got a very basic churn model up and running. I've done this before in my previous job using scikit-learn, and the difficulty really was aggregating data from different sources. Like in my previous job, getting data from like an Oracle database and a Hadoop database. So it seemed like that took most of the time, getting data from different data sources. Typically, the machine learning technology piece is the easier part, and more time is spent on getting the data and then figuring out the right features to use in our machine learning model. And so using Bigquery ML, getting used to the SQL syntax is like, anybody who knows SQL can be trained to do it within, I think, half a day. I think the tricky part is, like for someone new, is to learn some of the machine learning concepts. For example, if you train a machine learning model, how do you measure that you've succeeded? Like basic concepts like precision, recall, and accuracy, and AUC, area under curve. So those are more where more time is spent, like figuring out the features and then doing measurement of the result. And I feel like that doesn't differ from versus using scikit-learn or Bigquery ML, the feature engineering and the measurement. But getting used to Bigquery ML is very quick. You don't have to use any language. And then the cycle I was talking about, that data export, train model, data import, that cycle gets really reduced. So the number of experiments you can do using Bigquery ML, you can do a lot more experiments with this technology.
And is part of that because presumably they're scaling out the training behind the scenes and it's just a lot faster, or are there other aspects to reducing that cycle time?
Yeah, A is that it's a lot faster because of the BigQuery technology. And the second is what I mentioned before, exporting data for a machine learning model outside of the system, training it, and fetching that data back in.
Right.
So that gets significantly reduced. And the third one is, in our case, since our data was all sitting in one place, we didn't have to incur this ETL cost of getting data from different sources. Everything was sitting in BigQuery.
What are some of the other types of machine learning projects that you've done at Hearst?
Yeah. So another one was application of natural language processing. There's a case study published back in November. I think if you just Google Hearst and Google, that probably be the first link. So we've applied Google's natural language processing to all our content. So each of our tag, basically we're using two features of natural language. One is classification of content, putting this into broad categories, like if content is about food or wine, or is it about real estate? And then also a more detailed version of it that it tags entities in the content. And the entities could be proper nouns or common nouns with their metadata, with like their how much salient they are to that article, and also their Wikipedia link if they're popular entities. So we did that for all our content from all our websites, and that's stored in our CMS as well as also replicated into Bigquery for further analysis. So some of the use cases on this NLP data is, so we build out BI, business intelligent reports. For example, if you want to see how is, for example, a particular personality trending over time. So using Google NLP data and Google Analytics data and our content data and BigQuery, we can build out reports. And also, if you want to see which content categories get more traffic, like versus the content that we publish, like which categories should we be focusing on for publishers. So we build all sorts of reports using these three data sets. So this is one of the use cases for Google NLP. The other one is, which is more interesting, is that we also pass, like when we render our ads on thing, we've integrated that with DoubleClick for publishers. So whenever an ad is rendered, we also pass the key value pair of which category that ad belongs to, the category of the content that ad's being displayed. So we built, so over a month, this builds a database where we can say, show me all the ads that were displayed on, for example, Olympics content, or ads on our food content. So if there's a new advertiser that comes on board and he says that I want to run a campaign on, let's say, basketball or Olympics content, we build this capability using our tagging technology. So they can just specify criteria and DoubleClick for publisher, said, specify for this campaign, advertise this campaign on all the content which is related to, let's say, tennis or basketball. So that's another use case for natural language processing.
I know you've done some work both with Google's AutoML NLP that allows you to kind of fine-tune some of their models, but the classification was their off-the-shelf NLP service that one, if I'm not mistaken, you're not able to train that using your own data. Is that right?
Yeah, it's a good question. So the AutoML for NLP, which is another tool released recently, it works on top of the classification. So they gave a taxonomy of about 700 categories by default. But let's say if somebody wants to train their own category, like for some unique or novel content, they can use AutoML for natural language to train their own custom categories. So, and that works on top of the existing category. So if you make a web service call to this AutoML, it not only returns their default categories, but also the trained version as well.
And so you found that for the types of articles that you were initially trying to categorize, were these 700 built-in categories? Were they sufficient? was it, what was the experience of trying to map your business to this pre-canned AI service?
So most of the time it works very well. So some of the categories, like for most of our use cases, those categories work fine. There's a few categories which don't work well, especially there's sensitive content, so they don't really split out. So any article about crime or some violence, everything gets categorized into sensitive content. We would have ideally liked that to be split down into more granular, but Google thinks that there are like some restrictions. They just don't want to split that out. But one of the categories that we wanted, that I did a POC, was to detect evergreen content, because we had labeled about several thousand articles with evergreen label. So what evergreen means is content that has a life shelf of more than a few days or a few weeks. For example, an article which is a review of a museum, or an article about some real estate. So those articles have a longer shelf life. And it's very important in the newspaper if you can detect that type of content, because that kind of content can be used in recommendations. Even an article written 2 years ago can be reused, which otherwise would just be sitting there and nobody reads that content. So I built, using AutoML for text, I built a classifier which basically detects evergreen versus non-evergreen content. And our editorial, they helped us label this content. We asked all the different markets to take their content and label them with evergreen content. Initially, I did a very quick prototype using TensorFlow, and then I had a hunch that Google is working on this AutoML feature for NLP. And then once this feature came out, doing a POC was really quick. Like within a day, I was able to train an AutoML model that can differentiate evergreen content. So really the hard part in this is to get the label data. And the interesting thing is, once this model is trained, I even tried it on CNN and New York Times content, and it was able to differentiate evergreen and non-evergreen content. And right now we're incorporating that into one of our recommendation systems.
One of the things that I noticed a couple of times in our conversation, you're the senior director of data engineering and ML, but it sounds like for a couple of these POCs, you just kind of played around and put some stuff together. You make it sound really easy. It can be easy to experiment, but then if you actually want to use this in a way that the business is going to depend on it, there's at least traditional, a lot more that needs to go into it in terms of engineering. I guess there's maybe several questions in here, but part of it is like, does the cloud change that dynamic in your perspective, or are these projects that you built and then kind of threw them over the wall to some team that then had to maintain these projects?
Your question specifically about AutoML, or just about recommendations and the other stuff I've been talking about?
Specifically, I think with churn prediction and the AutoML, the impression I got was that it almost sounded like you got bored one weekend and kind of worked on these and kind of, you came up with these models in a day or so.
Yeah, so they weren't done in a day. They were sort of like the churn model we started when BQML was in alpha state, only available for certain customers. I think it was about May we started building it. So, and it took a couple of months, like refining and fine tuning it until, and we're working on another market, building out, doing this prediction for Houston. AutoML, it was in phases. We started off like last year. We said we need to collect the data since we want to be able to do things. So one mini project was to figure out how to get this data and get it labeled. And then once we had it labeled, it was just sitting there for a while till I did some prototyping work for using TensorFlow. And then when AutoML came out, it was, since we already had done the hard work on labeling the data, it was something very quick to do. So I guess one piece is that the project wasn't done like in a week. There were different phases and happened in different times. And the other thing is, in general, the newer features in cloud, especially the higher level APIs, it's much more quicker to do prototyping and getting things out quicker. And AutoML is a feature that's meant for people to do things much quicker. Like, you don't have to learn TensorFlow to be able to do it. It's just upload the data, give it labeled data set, and then it takes a few hours to train a model and start using it.
You've done some work on recommendation systems as well?
Yeah, so as I was talking, so one of the use cases with the NLP data that's sitting in our BigQuery data warehouse is to build a recommendation system. So the idea is that if two pieces of content, if they have overlapping NLP entities, they're highly likely to be related to each other. So this is content to content recommendation. And since we had this in our BigQuery database, we built out a recommendation system which actually works using a big SQL, which takes entities from one set of articles and matches up with another one, incorporates saliency score, and so there's a whole bunch of rules that we built out in our SQL, and produces a table of recommendations. And that's fronted by a web service layer that our website, San Francisco Chronicle, there's, I think, 3 websites that are using that content-to-content recommendation. And this was released as part of San Francisco's user interface rewrite. So a few months ago, we released a revamp of SF Chronicle. So this content-to-content recommendation was part of that deployment.
And so you've got this content in BigQuery, and then you're using Google NLP to essentially you're adding fields for each of the entities that are recognized, and then you're using Bigquery ML to generate a recommendation from a given piece of content to other recommended pieces of content based on these shared entities that have been recognized by the NLP service?
Yeah, so, and just a minor correction that this one doesn't use BQML. This is a plain SQL running, which basically is looking at the number of overlaps of entities between two contents.
Got it.
So it's basically scoring of how, like, based on the overlap, how relevant one content is to another one.
Okay. And then you said you're front-ending that with a website. Are you serving the data directly up from BigQuery, or do you push it out to some cache or database?
So we push it out. This computation is done on a periodic basis, about every 15 minutes. And that's about the frequency that we're getting newer content. So we build out a table in a Postgres database. And then that web service layer is using Memcache as well as this Postgres database to serve these out.
And you've also done some video content recommendations?
Yeah, so it's another project we've done is we've taken our video, converted that to sound, and then extracted text from that sound, and then applied Google's NLP to extract entities from the sound. So our content has the NLP tags, and our video using voice transcription, and using that text to also extract entities we can recommend video to content based on this technology.
And so to transcribe the audio, did you use the Google Speech to Text API for that?
Yeah. So Google has a Google Sound API, which given any sound, it can convert that to text.
And what was your experience getting reliable results from that?
Yeah, so our full objective was to also have captioning on the videos. So we did most of the time it works very well, the Google sound transcription, but in certain cases it doesn't. There were some few cases when it didn't work very well. So we haven't used this for captioning, but we took this text and it seems to work well if we apply NLP on it. If we just want to extract categories and tags from it, for that purpose, it works well. And those tags are used for it eventually being able to recommend textual content along with the videos.
Any final thoughts or words of wisdom that you shared as you were wrapping up your presentation on these use cases?
Yeah, so some of the advice I gave was that some of the things that we want to do in the future is to apply deep learning for recommendations. There's a lot of research done in the past couple of years for application of deep learning in recommendation. We're actually doing some research and we want to launch very soon with a recommendation system that uses deep learning. So I'd recommended that we should use and everybody should look into deep learning and TensorFlow. So it's really everything. You don't have to build from scratch. If a problem is already solved by higher level APIs such as the NLP, image, video APIs, or BQML and AutoML, we should be using that. It's really a trade-off. Do you want to hire a data scientist to rebuild this thing, or do you want to just pay for that service and apply it? And only in cases where the problem is novel or the data set is novel is when you want to build your in-house machine learning model. For example, we want to be able to do recommendations using deep learning. So this is something that we're building in-house. And other things that we're exploring is more use cases for NLP. We identify that we can use this with our newsletters to be able to generate newsletters automatically. That's something that we're looking into. And also more uses for Bigquery Ml. Just like churn, we can do the converses, do propensity modeling, like what's the likelihood of a user to subscribe to one of our websites. So this is overall our future plans.
Awesome. Well, Naveed, thanks so much for taking the time to share what you've been up to with us. It's been really interesting, and I appreciate it.
Okay, thank you very much.
All right, everyone, that's our show for today. For more information on Naveed or any of the topics covered in this episode, visit twimlai.com/talk/182. If you're a fan of the podcast, we'd like to encourage you to visit your Apple or Google Podcast app and leave us a 5-star rating and review. Your reviews help inspire us to create more and better content, and they help new listeners find the show. As always, thanks so much for listening, and catch you next time.